Going to talk about encryption. I have a teenage nephew who is learning Python these days, and he happens to be very interested in war games as well. So he came up with this idea to convert a sentence to its encrypted form. In this process, what he did was he wrote two functions, one which could encrypt the data using a certain key, and then he would feed that encrypted key into another function, which is the decrypt function, and he would get the original message. What he did was pretty simple. He took the characters that were there in the message, found the ASCII code for those characters. For example, character A has an ASCII code of 97. He would then add the key to that ASCII code. So if you add 9 to A's ASCII code, it becomes 106, which is the ASCII code for J. Similarly, he did this iteratively over all the characters that were there in the message, and he received the encrypted text back from it. And then in the decrypt function, he would uh, he would subtract the same thing again and get the decrypted output. This is pretty simple this is pretty simple, and you would relate to this as well if you have heard about things like rot 13 or rot 9 in this case. Now I wanted to take this a step further and tell you how this relates to symmetric encryption. In the symmetric encryption, we have a message which is encrypted using a certain key. Now in the production systems, that symmetric encryption key is pretty complex, but it still brings us to the same point. So we are having a message which is encrypted using a key, and we get an encrypted message back from it. And then we take that encrypted message, we use the same key in order to derive the original message from it. This is symmetric encryption, in which you use the same key. Here, it's the same key for encryption and same key for decryption as well. Another form of encryption is called asymmetric encryption. You will see this commonly in when you go to an HTTPS website and you find a key at the top or a padlock at the top. So that uses a form of asymmetric encryption in which there are two keys instead of just one key. There are now two keys. There's a public key and a private key. And these public private key pairs are generated using an algorithm called RSA. RSA algorithm, you might have heard about OpenSSL, which also allows you to generate this kind of public private key combination. How does this work? So you have a message which you wrap with a public key. It results into an encrypted message. And then you take that encrypted message and use the private key to decrypt the message. So you take the message first, you use the public key with that message, it results into this encrypted message, and then you take that encrypted message, use the private key on top of it to get the original message again. In this process, there is someone who owns the key, and the person who owns the key has two pieces of it, one the public key and another the private key. And this key pair, as I discussed, this may have been generated using OpenSSL. The private key is generally secured by the owner, and he shares the public key with some with people with the audience or with people, so that they can encrypt the data that they want to send to this owner. So if you want to send any data to me, I will give you the public key. You will encrypt that data with that public key. You send it over to me. and I will decrypt that data using my private key. This is also called public key encryption. How does this work? So if you want to visualize this, think about two people, Alice and Bob, very commonly used in the encryption terms, Alice and Bob characters. So you have Alice who has his own, who has her own private and public key, and Bob who has his own public and private key. Now, if Alice wants to send a message to Bob, if she sends the message directly, there is a possibility that someone here will be able to read that message. What they do instead is they exchange the public keys with each other. So Bob gives his public key to Alice, and Alice gives her public key to Bob. Now, if Alice needs to send a message to Bob, she uses the public key that Bob has provided and wraps with that public key and sends that message. Now, since Bob has access to the private key, he is the only person who can read that message. Similarly, when Bob needs to send something to Alice, he will use Alice's public key to wrap the content, and then Alice would be able to read that content using her own private key. It turns out that all of this is mathematics. And so when my nephew did this exercise, a simple mathematics exercise with his code, I was interested to find out if same thing could be done with the asymmetric encryption as well. So I looked at Wikipedia and it turns out yes, but the the numbers that are generated are more complex than what you would be able to use in a simple symmetric encryption. So in the asymmetric encryption, you need to have a pair of numbers instead of just one number, one which would act as the public key and another which could act as the private key. So in this case, if you see this, we have derived these numbers through all these steps, and then we have reached to a public key which is a number which has two pieces, uh, N and E. So this number 3233 and this 17. So this combination is the public key. And with this number, we calculate the value of C, which is the encrypted string that the person has. So we will use this 123. And so if we want to send the message 123, so we take this 123 and we use this formula to the power 17 mod of this number 3233. So we get 855 back. Now anyone could get 855 back. What now? How do you read that? So the person who holds the private key knows that the private key has these two values, and he is able to use those two values into another function which is able to give the number 123, the original number, back again. And so I wanted to test this out myself. And in order to do that, I went to this website because these are power numbers. So in order to calculate them, you need you might require more space than the normal numbers that you compute on, and you might need some libraries in order to work with that. So I simply went to this website where I feed in the number that we just talked about. So our base message in this case is this number 123, which we want to encrypt. And these two mathematical numbers, these 17 and 3233, have been derived from the equation. So we encrypt that number using these two numbers, and we arrive at this number 855. And then corresponding to this, which acts as our private key, we take this encrypted text, which is now 855, this encrypted number, and we feed two new numbers to it, to the formula that we just studied earlier. So we use that to arrive at the original result. In this case, this 123. So we use 855 is the encrypted number, and we use these two numbers in order to reach uh, to the to the original value. So I hope this video was interesting to you, and I hope you learned something about asymmetric encryption. And I look forward to see you implementing this piece in your own language of choice. Let me know if you are able to do this, and I would be happy to answer any of your questions. Thanks a lot. Bye bye.